Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Hey, hello everyone, Bruno here. Hey, super happy to do this. Is the PM session, so this is the second time that we are doing this. We ran this with Don earlier today, and it's supposed to be better. We learn our lesson, we learn our stuff, so we bring a couple of new things here. Ravi was asking there a couple of things. Hey, we are going to talk about voice agents, NVIDIA models, Azure, Foundry, and more. I'm super happy to be here, and also happy to be with Don. Hey, Don, how are you?
Hey, Bruno, doing well. I'm excited to do this presentation with you. Yeah.
Perfect. Nate, I am the worst host ever because I learned this. I ran the .NET and AI show. I've been running that for 3 years and more and other shows. And I always forget to introduce myself. So my name is Bruno Capuano. I work at Microsoft. I'm a cloud advocate. And we also working in GitHub right now, which is super amazing. Nate, my main job is to basically learn and share about AI and get your feedback and try to figure out what are you learning, what do you need, how we can make your life better at the same time that we show amazing things. And I am super happy because from time to time we also have the amazing chance to work with people who I really like Don. And hey, Don, can you introduce yourself, please?
Yeah, thanks. Yeah, so I work at NVIDIA and I'm a content creator. So I get into whatever the hot topic is that needs content created, including this.
Yes, and this is super fun. So I am going to bring your slides. Here they are. And hey, Don, it's all yours. Let's start here with what we are going to see.
Thanks, Bruno. So you came here to build a voice-enabled AI agent in minutes. That's the promise, and we're going to fulfill that promise. I'm going to make sure that you have some context when you leave this in terms of which parts of the Azure AI platform you want to dig into to make your AI applications, which NVIDIA AI technologies are available on that Azure platform. And then we'll hand it over to Bruno, where he's going to show you a speech AI demo where he's running the model locally. And then he's going to run it up in Azure. And then he's going to run it as a NIM. And you're like, what's a NIM? Well, I'm going to cover that. I'm going to cover all the key concepts that you need to know so that you'll be able to follow everything that Bruno's going to do. And this slide, I apologize, it looks like the periodic table of the elements. There's a lot on it and it's overwhelming. But after this webinar, this is your friend. This is your cheat sheet. This is, if you clicked on these are all links. If you click on each one of these links and read it, you'll be an expert. You will totally be an expert about NVIDIA on Azure. Now, I collected them into 5 different categories. Obviously, if you're going to build an AI agent or any sort of AI application, first thing is you need to choose your tools. You're going to build apps and agents. You're going to need tools. Then data is king when it comes to AI. Garbage in, garbage out. So you need a data strategy. There's tools for that. And then you're going to, of course, select a model and then customize it, maybe fine-tuning, maybe some sort of RL or whatever you're going to be doing to customize the model. Then you're going to want to deploy this application, and there are technologies to do that. And once it's been deployed, of course, you have to make sure that it's operating correctly. In case someone needs to step in to do something, make sure everything's secure and so forth. Now, I'm going to assume, since we've got the Microsoft audience here, that you already know all the Azure technologies. So everything in blue, right? You live in Visual Studio Code all day. I don't need to tell you much about it. You're going to see Copilot Studio. So from NVIDIA, what we bring to this part of what needs to be done is we have these blueprints. Okay, and I have a slide on that. I'm going to show you a little bit more about the blueprints. But for now, just remember, NVIDIA has a number of blueprints, depending on your use case, that'll really get you started quickly, to use a combination of models. And I actually have an example of one that I'll show you. Then there's the NeMo agent toolkit. And then when it comes to the data strategy, we have microservices that help you get at that data. There's Curator and Data Designer and Safe Synthesizer and Retriever. And you'll hear a little bit more about those. When it comes to models, there's the NVIDIA Nemotron family of models. We also have a NeMo. NeMo's the tool, right? So we have the NeMo tool that called Evaluator that helps you compare one model to another. And at this point, you're like, well, wait a minute, Microsoft already gave me an evaluator. I don't need yours. Well, yeah, you do. They're up kind of at a higher level of evaluation, and we're like way down in there, like optimizing GPU and so forth. We, for instance, have over 100 academic benchmarks that are part of NeMo Evaluator, and this is all open source, by the way. Everything we do is open source. So then there's the NCG Hub, where you can, it's kind of like, think of Hugging Face, place where you can go get a lot of really good things to use in your development activities. When you deploy, we've got NIM, we've got NeMo microservices, and we've got Run AI, which helps to orchestrate Kubernetes. And then we have a new inference server for the very latest chips for the ultimate performance, which is called NVIDIA Dynamo as well. And then lastly, guardrails and auditor to make sure that everything's going to, be safe and secure. So what then is Nemotron? Well, it's not just models. That's what a lot of people think. And that's why I've pulled this slide into the presentation. It is models. You see them there, right? The Nemotron 3, the vision language model, a whole family of models under Nemotron speech, a whole family of models under RAG, a whole family under Nemotron safety. Okay. We also made open, and those are open models with open weights. Okay. We also made available to the left of that data that we're using to train these models. So you can use it to train other models or fine tune. Nice data sets there. Those are all open, ready for you to use. Libraries to help you in your endeavor, training scripts, and as I mentioned earlier, blueprints for some key usage scenarios, like maybe you're doing a deep researcher that's going to go through a bunch of documents. Well, we've got a blueprint for that. Maybe you want to summarize a YouTube video in a few paragraphs because it takes an hour to watch them all. Well, there's a video search and summarization blueprint, right? Maybe you're a typical enterprise that's going to do a RAG application, because if you want to get a return on AI at your company, just do a RAG chatbot. It's that simple. It answers questions. It goes into your documents. It's either going to make your customers happy or it's going to make your internal people happy. It's going to increase productivity and so forth. It'll be a hit. RAG chatbots are always a hit. And then beyond that, of course, are agents that can get much more active in thinking and reasoning and going and doing things for you. The model that is available right now that people have been playing with is Nemotron 3 Nano. That would be the latest. And you see here it's 30 billion parameters, whereas an active at any given time, only 3 billion. Now, where's the first time you saw that? That's mixture of experts. Okay, why should, when a prompt come in, why should I light up every single node in the neural network and burn all that electricity if I can quickly ascertain that it can go over to an expert that's only going to light up 1/10 of the nodes of the neural network, cutting your electricity bill to 1/10, right? So we love MOE. It's great. And plus, all the little experts can be individually trained. They can become really, really expert in their little niche. So it's a nice architecture for a number of reasons. And it's supported by our hardware. Next is Super. We're working on that. It's bigger, so it's we're training it. Still training. Okay, it's going to reach closure, but still training. We don't get we only get so much hardware because we try to sell it, but our people need it too. And then there's Ultra. And then we've got, again, the NeMo Gym, all the open research and so forth that comes with that. So let's take a look at this Nemotron 3 model. What a lot of people are doing with it is they're using it to do advanced reasoning. It's kind of like about the right size in there at 30B with 3B active. So what do you mean it's leading in advanced reasoning? Sorry about this marketing slide, by the way. Why do you say that it's leading in advanced reasoning? Well, here's your benchmarks across the bottom. You might be saying, well, reasoning is about coding. No, it's about scientific reasoning. No, it's complex math. That's the key there. If you can do that, then okay. So in each of these industry standard benchmarks, the green bar that comes first is Nemotron 3 Nano, and we win. And we're putting ourselves up against some very worthy competition. We've got Qwen 3 and GPT-OSS 20B. Very nice models. Here's an example of a blueprint. Let's say I wanted to do some deep research. Okay, we're going to start over in the left there. You're going to take some enterprise files that you want to do research on. I don't know, maybe a whole pile of PDFs, tens of thousands of PDF files, let's say, manuals or whatever it is. Those have to be chunked. You've got to chunk them. So that's where our extraction Nemotron goes in and has a very advanced strategy for how it's going to get into that document and start reading the different sections of it, like a graphic versus text versus a table, and these things, you can get more intelligence out of it when you do it right. And then take that information once it's been isolated, and then of course you need to create embeddings. You need to create embeddings so that particular data chunk can be put into the vector database, so that later you can find other chunks like it, right? Using semantic similarity searches against the vector database. So that's it. Got my enterprise files. I've ripped through them, gotten all the components out of them, and now they've been put into the vector database. I'm ready for business. Now comes the customer. It's either some upper left. It's either some user or some machine. And in comes the prompt to my application, which is an agent. And because it's an agent, it reasons. So it's doing planning and reflecting and refining. And eventually it's going to have an answer, and it's going to use a report generator model to get that all put together and hand it back to you as the report. But as part of answering your question, it's going to go down, and you see it's going down to the right. It would just like go out to the web to get data. That's cool. Or it might choose to use a more internally focused tool. So it's going to the left, and it's going to actually use a Nemotron model to get all of the chunks out of the vector database relevant to your query. And then, very important, because this brings up accuracy big time, you got to re-rank. You can't just take those chunks. You need a re-ranker that specifically takes chunks and ranks the most relevant ones based on the way the prompt came in and what's going on with the conversation. Okay. So this is just a blueprint. See, it's always using a combination of models, small language models that can be trained and refined. There's other models too, not just for reasoning, which we've covered here, but we've got vision models that can understand, vision as well. There's models for information retrieval, models specific to safety, and the names are all here in the green, okay? And then there's our speech models, which is Nemotron automatic speech recognition, which you're gonna be looking at today. In fact, Nemotron speech is like an umbrella, and there's a whole bunch of models in there. It's open source, state of the art, and has these attributes, and it's industry leading. If you look at the leaderboards out there for speech recognition, our models they dominate. Here, for example, are the two that you're going to see later in the webinar. You've got an NVIDIA Parakeet model, and then the NVIDIA Canary model. And Bruno's going to exercise those for you. I'm going to cover a few more concepts and then hand off to him. What are you going to do with your speech model? Well, you could do a quick demo just to make sure it works locally and remote and so forth that we're going to do today. Or you could build it into something really big for your company. Some QA assistants or chatbots. Maybe you're going to use it in the contact center, creating digital avatars, doing translation, video conferencing, AI robot, and all sorts of places need speech recognition and production. Now, when you're on Microsoft Azure, you're obviously using Microsoft Foundry, and so our models are right there for you, right in the place that you trust. You could also come to NVIDIA, get the models there, but you'll find everything you need right in the model catalog. And here, someone started typing in NIM, so this is a subset of the models that would be appropriate for that search. And Bruno will search for speech when he does his demo. And so we've got this toolkit for you. It's open source tools, just to make you be successful. Because when you're successful, we sell the GPUs, right? So we want you to be successful wherever and with whatever software, and run it on NVIDIA GPUs. So at the bottom is the NeMo framework that is used to train models. And then on top of that are some microservices that we've built that if you're building an AI application, you probably want to use some of these microservices like the data designer or the safe synthesizer or the customizer or evaluator or guardrails. And then on top of that is another layer of the layer cake where we have a toolkit to help you build agents, the NeMo agent toolkit. And immediately you think, I don't need that. Azure gave me everything I need to build agents. Well, yes, they did. But this agent toolkit, this one drills way down into we're like way deep down in there. Okay, so this is complementary to the one that Microsoft gives you. That's
yes, I'm sorry to interrupt, Don, but early this morning, someone asked, hey, in Microsoft, we have another framework to build agent, which is called the Microsoft Agent Framework. And then we have here the NeMo Agent Toolkit. So is this the same tool, similar tool, they compete each other and more. And what I really like about these days when we talk about agents is that this is one of the few times in history that all of the big names in the industry, you can think NVIDIA, Microsoft, Amazon, Google, and more, they all start agree on standards. So we have standards for AI applications like it's the Model Context Protocol, the MCP. We have a standard on agents, how agents can communicate together, which is called A2A, agent to agent. It was created by Google last year. Now it's managed by it's a protocol and a definition that is managed by the Linux Foundation, as far as I remember. But the cool part about this is that, in example, the agent toolkit supports A2A. So you can build an agent there, and the agent will be kind of A2A, agent-to-agent compliant. If you build another agent in agent framework, that agent is also agent-to-agent compliant, so they can talk between each other. You can build different agents, and you have, I don't know, one agent there to do document reviews, one agent here to do translations, and then you have another agent there, which is a finance expert. Hey, when you work with these standards, you literally try to forget where the agent was created, in what technology and more. You know that it's going to be there, you know it's going to be running, you know that you can talk and you can orchestrate and work with this. And this is super cool. I literally, when we talk about this morning, I literally build in 10 lines of code an agent with the agent toolkit. Of course, it's a hello world agent, not a very smart or whatever. But hey, after that, you can put that agent to talk with any other agent that support A2A. So an example that we have in Foundry, which support A2A agents. So it's super, super nice that all of these tools and all of the NeMo, I become a fan of NeMo in the last couple of weeks, all of the NeMo tools and more also follow this standard because it literally makes our life easier. If you already been working with one framework that supports A2A or do agents in the standard way that we've been doing, ABC is going to be here. It's going to be easy for you to start. And I'm sorry for interrupting, Don, but that point was a question in the morning. I think it's nice to mention that it's kind of a nice ecosystem that everything fits perfect with each other.
Yeah, it's perfect. And the prompt to give ChatGPT is compare and contrast the Microsoft agent, toolkit with the NeMo agent toolkit. That's what I did. And it came back and I'm like, oh, right. These are complementary. They're working at different levels. I would use both. So not that I have, but I would. Okay. Now let's take a look at these NIM. This is another big subject when it comes to NVIDIA, and people get confused about it. I think it's because of some of the early slides that we put out on this, but it is very, very simple. It's a container. NIM is a Docker container, and inside that container, of course, because it's a container, you can run it locally, right? You can run it up in the cloud. It's just a container, just stand it up. Probably Kubernetes if it's a real application running in the cloud, and probably not Kubernetes if it's on your local computer. But they're easy to deploy, easy to use. And what's in the NIM? Well, it includes the models. It also includes inference engines, and it's completely enterprise supported, and everything has optimized performance. So one of the things, if you look in the very top of the slide, it says standard APIs. And so what we're going to do is we're going to take a model and we're going to stand it up and expose it as an endpoint that you can go in and and use it. So that would be, why not be OpenAI compatible? Why be different with the industry leader if you don't need to be? Now, some models might need to be a superset, but for many things, it's just OpenAI compatible calls that are going to happen to that model, which is running on Kubernetes, which is taking advantage of the CUDA hardware underneath. Here's a little, and these are optimized on when you go to get these NIM, you can get them from build.nvidia.com. You can get them from Azure. When we go to stand up the model, the runtime that we're going to use to actually run it is selected based on your hardware and the model that's in the container. So we've got on the left, I don't have the evidence here, but we certainly have it on our website, that we took a model, and with NIM turned off, it ran at a certain speed. But once we used the optimized version that was inside a NIM, performance doubled. So you don't want to ignore NIM, because anything that can double your performance, you need to pay attention to that. And so you can see it here. It exposes in the picture, you got your client API coming in through HTTP, right, to the OpenAI compatible API. Oh, look, there's FastAPI in there. Yeah. Well, we're gonna be serving out answers. We're gonna need some way to do that. So we've got FastAPI in there, and you see the paths, and then it's gonna have the LLM executor is going to choose the correct runtime based on your model. Maybe we'll run it with a VLLM runtime, but it would be better if we, it's the type of model that we can run with a TensorRT LLM runtime. Those run really fast. So, but whatever it takes, that's what we'll load and run. And that's it for me, other than to say, I know I covered a lot of information here. You've got the click links and a quick exposure to the concepts. And to go further, here's learn.nvidia.com, and also join our developer network. You're going to need that anyway to get the key to use the speech model that you're about to see. So sign up for our developer program, because you're going to, of course, do all the Azure development stuff that you've always done. But now you got to join the NVIDIA developer program too, because we got some goodies for you to use on Azure. And with that, I'll hand it off to you, Bruno. Let's see this in action.
Perfect. And hey, let me share my screen quickly and let's do some magic. Oh, there it is. So we have Anna in the back helping us. And hey, we saw a lot of stuff here, and people who know me knows that I like to build something that is useful, that's something that I can use and test and more. So when we first start to talk about this, I was doing something with my podcast and more, and I was started to think, okay, I have an automated process where I do everything there, but I want to do some transcripts of my podcast. And that's the moment that basically start to say, hey, there may be something there. So literally with these links that we have here, with NeMo repository, the documentation, and then a couple of models, I built something that now it grows until what we are going to see. All of the links are going to be available in a repo that we are going to share, but let me also share with you the way that we are working today. Me, my team, and my colleagues, we all use Copilot. We use Copilot a lot, and we use Copilot to code. We use Copilot to help us learn new stuff, to review code and more. Right now, Copilot is kind of one more in my team, is one new agent or a set of agents working here. And the nice things about Copilot is that Copilot comes in different flavors. You can have Copilot as if you're using Visual Studio Code or Visual Studio or any JetBrains IDEs or more, you are going to see that Copilot is there in your IDE. But you can have Copilot now also in your command line, the CLI. You can even have that in an SDK, that you can create an agent using agent framework, using Copilot internally, and it's going to be exposed. So there are different ways to do this. And if someone asks me how we do this, let me show you a real example. So as I said, this is I am going to start Copilot here. Let's do Copilot with banner, because I like to take a look at this small animation there that is start Copilot. I have the 0.407 ready to work. I'm using Cloud Opus as the model. I have a new version. This is cool. Every minute we have a new version. So I already have a new version. Not going to restart it. I'm going to restart it later. But from here, I can change my models. In example, I can do models and start to select another model if I want. I am going to keep Opus 4.6. And what I like to do when we work here, the medium, let's go for the balance. What I like to do when I work here is that basically we have different ways to work. And when you started to learn something, I always advise people, I always tell people, hey, do not go directly and start to write code, because these LLMs are very good, but you can even probably start to learn what to do. So I'm going to change the way that I am working here. And instead of working in the standard coding mode, I'm going to switch for plan. And I am going to also paste this instruction. I'm going to say, hey, I want to create a short Python script that will generate the transcript from an audio file. Let's use the NVIDIA Parakeet model running locally. Let's start with the smallest model. I want to run everything locally, so I want to start with the smaller that we can use. And with that simple prompt, a couple of things are going to happen. So Copilot as an agent is going to start to search the web, to search other resources. We can see here, start to read some files that I have there, and it's going to, it's going to do some disk activities. So it's going to ask me every time that these agents are doing activities that may require, I don't want you to rewrite my disk. So no, don't do anything. No, that folder is fine. So yes, work there. Yes, add that to the list, add that to the list. So it's going to ask me a couple of times. And after a moment, it's going to have all of the huge set of information. Is going to download kind of a plan. And at the end, what I wanted to do is to have this plan of how I can use these models. And you're probably wondering, why did you choose Parakeet? Why did you say NVIDIA Parakeet? And let me show you why. By the way, Copilot is still working with me. As I said, it's helping me. So it's going to say, okay, you want to do that. How do you want to do? It found a script. We have a script there. So what do you want to do? Start first, because we can create a new script, enhance the existing script. Let something there. Hey, the one that we have right now looks good. So verify that it works, or do something else. Let's go something here like create a new script for a new demo. So let's go into ask this for this, to ask the plan to do something else. But in the meantime, as I show you why I went to Parakeet. So a couple of things happened there. I went to Foundry. This is Microsoft Foundry. This is the home of where we do all of our stuff on the cloud. You can see here, I'm in my Discover, where we can start to browse our models and more. And when we are with our models, we can search here for the collections that we have by capabilities or by inference tasks. When I went here and I select ASR, automatic speech recognition, I see that, hey, all of the first options that I have here, they were all NVIDIA stuff. All Parakeet, and this is me 1 month ago, 2 months, I can't remember. When we first started with this, with Don and the NVIDIA team, I said, oh, this is amazing. There's a lot of options here. I really didn't know what was the difference between Parakeet, RNNT, and TDT, and CTC. But hey, there was a lot of Parakeet stuff there. And what I like here is that I can pick up any of these models, and as any model that we have in Foundry, I can deploy it. And I can deploy it literally here, use this model. I'm not going to do the full deploy right now, but I can deploy it and start to use it. and it's going to run in the hardware that we have in Foundry, and it's going to expose an endpoint and more. So we are going to have a lot of models ready to use for NVIDIA. And if you want to know more, of course, you can go to the card of the model that is going to redirect us to Hugging Face, where most of, probably all of the models are right now, and we are going to see the full documentation and the full description, the model card and more. But with all of this, I have the sense that, hey, I can do something, and I can create something, and I can build something. My idea was to build something first locally, and then move it to the cloud. So start to do with the prototype that runs in my machine, and then move it to the cloud. And let me show you what I built. And what I am going to show you is a video of a live agent running locally using Parakeet to do the voice. I can't remember the model that I used to do the speech to text. Then I use a tiny llama, which is a very, very small model. This is all running on my machine. And then I can't remember which model I used to do the text to speech, but this is another NVIDIA model. And hey, this is all happening here. And let me play the video. Hey, I have a question. What is the capital of Canada?
The capital of Canada is Ottawa, located in the province of Ontario.
And what is the capital of Italy?
The capital of Italy is Rome, located in the region of Lazio.
And who is winning with most gold medals in the current Winter Olympic Games?
As of the end of the Winter Olympic Games, the country with the most gold medals is the United States, with gold medals. The next closest country is Russia.
And okay, yes, you know the deal. This is giving me wrong information, and this is because this tiny llama, I can't remember the exact date, but I think it was trained with information until the end of 2025 or something like this. So it literally doesn't know what is happening right now, which makes sense. This is the moment that these agents need to be connected to the cloud, or any other database where they can fetch all of the information. But what I really like about this, what you've seen on the left, is a custom GPU. It's a custom GPU viewer, because I like to do things in a different way. So I friend vibe code the viewer and I tweak it a little. So that's basically show how my GPU was working. And as you've seen, it wasn't using a lot of resources. These are a small model, very optimized, that works here. If we go back here to Copilot probably still working. Yes, it's going to ask me, what do you want to do? Console output, yes. Or maybe let's do console output. And after a couple of questions, and by the way, I can say, don't ask me, I can create a plan and don't ask me anything, and Copilot is going to do, it's going to ask me the name, and after that, it's going to have the full plan. But if you are wondering, okay, and how difficult is to do this, let me show you the code. Let me show you what we have. Before going to the code, everything that we are going to see, all of the demos and more, are part of this repo that we are going to, as far as Anna told us, and as far as I understand, you are going to get an email with all of the information, including the repo. The repo also have all of the links that we mentioned in the slides. And we have different scenarios. So the first scenario is the simplest one. The number 5 is what we see in the video, which is the voice agent here. If we go to scenario number 1, I'm going to do this here. I have here scenario number 1, not 4, let's go for 1. And I have here a very simple, very, very simple Python script. Yes, I know, I am in the .NET team, but I also do Python and C++. When you are a programmer, you love languages and more. And the steps that you have here, what I like about this is that when I was learning NeMo and how to use these models, it's a super AVC. It's super amazing in the simple ways that you can do. And I saw a question here, a couple of questions around an example. Alden said that she don't load Mass Whisper for video transcription. Hey, and to try this one, take a look to the Parakeet. I used Whisper in the back, and it was a very good model. I like it, but I was really, really happy, and it was a wow moment when I see how well Parakeet works with audio and also video, because you can extract the audio and then work it there. It's very, very, very good. If you have a nice GPU, it's going to work amazing. So hey, go for it. And as I said, going back here, what is the AVC that we need to do to convert audio file to a transcript. So first of all, step number 1, we are going to get the name of the file. Step number 2, we are going to convert the file to a specific format. That's the format that the model requires. Step number 3, let's go into load the model. And this is the moment that the model is going to be loaded in memory, and we are going to see that it's super fast. Step number 4, we have the model, we have the file, start the transcriptions, and that's it. We don't need to do anything else. I mean, I have a couple of tweaks here where we are going to fix the name of the, we are going to have this in the specific transcript format where you have year, month, and hours, and minutes, and more, but load the model, drop the file, get the transcript. And it works great. Let me show you this working. Let's go here and let me minimize this. Still working. Yes, show this. Let's minimize this. Copilot is still working. It's very chatty right now. And I am going to start here in the left, the GPU viewer. So we are going to see what we have. And here, let me start my terminal where I am going to go to the scenario 1. Here we have a couple of files. One of the files is a transcribe. So let me do here, and let's do Python, simple transcribe, and I need to pass the name of the file. I have an MP3, which is only 30 seconds. I didn't want to do a big MP3, but we are going to transcribe another one. And when we run the script, and this is this is literally the code that we just seen. First step is going to convert that MP3 to that specific format in a WAV format. And then after a couple of seconds, it's going to load the model. As we've seen in the left, the GPUs are not doing a lot of work. And by the way, this is me writing code in the simplest ways ever. I am going to show you later how you can really, really get there. We have a couple of spikes here. That's the model load and working, and that's it. Then we have here the transcript of the audio, which is, hey, hello everyone, Bruno here. And if you are following my blog, this is the first 30 seconds of one of my videos. It works very, very good. And it was super fast. And by the way, this chart here is literally my GPU viewer that we have here with a little spike here. And my guess is the first spike is loading the model and the second is the transcription. But if you're, then I don't load the model. But if you keep the model in memory, you're going to see that only you have very small spikes that the GPU working. It's super, super efficient. So my next step here was, okay, this is fine, this is working, but I want to work here with the Spanish podcast. My podcast is in Spanish, so I have Spanish audios, and I find that Parakeet, it works great in English, not in Spanish. So my help here, let's see if Copilot finish. Copilot finish. So yes, we have the plan here and say create a file. So we have the step-by-step process. So we have it's done a lot of things. And by the way, if I said to Copilot right now, start, it's going to write something very, very similar to what we just seen about how we can generate a transcript. But I am going to say something else here, like an example, my audio files are in Spanish. Which model should I use? So I'm going to ask Copilot here to think a little more, and this is the moment that is going to probably suggest me to say, hey, you know what? Parakeet is good for English, but for other languages, we have other models. So I am not going to wait until the answer. I already have all of this documented for you, and this is the moment that we switch, because the documentation help us and more, we switch to start to use the Canary 1B, which is a multilingual model. And this is literally the same piece of code. If I go to the third scenario, I have more files here to test. But if I go here and open the code, what we are going to see is that it's literally doing the same. But at this moment, we are going to load. Let me go to the top. This is more well documented. This is how we are supposed to write code. But somewhere here, we are going to say, hey, you can use this model, Canary V1, 1B, V2, sorry, and these are different ways of Canary. And then you also have Parakeet here, and then you can define which language do you want to use, which file do you want to do, but the full process is the same. First, convert the MP3 to a WAV format, then we have here load the model and more, so it's going to do all of the things that we've seen. If I run this again, and let's pick up here our we have here the options that we are running. So still saying, okay, you need to do the V3, the Canary one V3, V2, and more. So Copilot is doing all of the research for me. I really like that. Copilot helped me to do this. And if we run this, let me go back to our GPU. Let's go to scenario 3. And let's maximize this. And let me run here the transcript. This is going to show me a couple of options. So it's going to show me, please, when you create console applications, add helps. We really appreciate helps to understand the arguments. So the arguments are the file, the language, and the model. These are the models that this script is prepared to use, and the language that the model supports for Canary: English, Spanish, German, and French. So what I am going to do, no surprises here. Let's do this again. And my file is end-to-end 471. And this is another 30-second audio, an MP3 audio, but this one is in Spanish. So this is going to do literally the same, but using Parakeet. What I really like when I was doing this is that in order to do this, I am using NeMo libraries in Python. So there is a full stack of libraries that we can use from NeMo, and they're very good and they are very similar. And they are going to basically abstract me to understand the difference between each one of these models. And I can use these NeMo libraries and say, hey, load these models, load this other model, and do your magic. And as you are going to see now, is going to load the model. It's going to take some time. We start to see the spikes in the GPU. This is probably the load in the model. And after, there it is. And after a couple of seconds, we are going to have the transcripts also in Spanish. And it works really, really well. So, there it is. The model is loaded. Oh, have a huge spikes there. I'm doing something else with my machine somewhere. And we are going to have the transcription at any moment. And it works great. And it was great on the sense that I can do all of these things here locally. I can start to work and I can start to do my transcript. And remember, is pick up the file, pick up the audio, convert it to WAV, then load the model, and then generate the transcript. It's taking forever. Oh, there it is. And this is it. This is sorry for non-Spanish speaker, but this is hello. Welcome to another episode of Not in a Nombre. That is my podcast, yada, yada, yada. And it works great. And I love it. And I say, hey, I am going to do this. I can do this. I can generate transcript in a very good way. And as we've seen also in the voice application, I can work with chunks. So you have the feeling that it's working literally fast. But I want to do more. I create enterprise applications. So how about if I go to a client-server scenario where we are going to probably have a server on the back that is going to load the model and have an endpoint that where I can drop an audio and then get as an output the transcript in SRT, in text, or other format. So that's kind of the idea, and it's literally what we're going to see in the next scenario. But I see, I like these comments here that Satya PE70, sorry, I'm the worst with names. I'm going to play my non-English speaker here card to say sorry if I say your name bad, but said that did similar project for one of the research projects in the Web for All Accessibility conference this year, working in ASRs and TTS for 14 years. How do we use the models? Are they open source? Yes, I was going to go there, but let's break a little the flow. We're here to answer questions and more. So you can download this model, an example for Hugging Face. NeMo is going to help you download this model if you want. By the way, by default, let me go here to the top. I want to show you one of the messages that we have here. There it is. So by the way, the first time that you use NeMo to load one of these models is going to download the model, and it's going to, so the first time is going to take some time. This is a 1.5 gigabyte model, so it's 1.5 gigabytes to need to download, but then it's going to be stored in a cache, in a local cache, so you can reuse this. So the first time is going to take some time, and then it's all yours. They are free, they are open source. You can see all of the infos if you want on Hugging Face, but my advice, and I think it was also Alden that was talking about that, is that, hey, you can start here. This is where I start, and this is where I am learning to basically do my local stuff, work with model and more. you can create an account, go for buildnvidia.com, and this is the moment, this is the place that you can start to search for your models. So in example, if I go here in models, let's pick up the, what I did, models, and then I say, I don't know, Parakeet, the filter for Parakeets, and this, I think this is Chinese, CH, this is probably something Asian, I don't know. And when you open one of these, it's Chinese Taiwan. So you can use here the model, you can start to see the model card, you have the API if you want to use it, it's all going to depend on your accounts and more. You can deploy it here, take a look how you can deploy it with Linux and Docker, and NIM, we are going to get there later. But yes, most of these are open source, most of the stuff is open source, you can get here, and the developer platform that NVIDIA have is as a new person here, I'm super happy as a developer because it has a lot of documentation, samples, and more. I think it was Alden who was talking about the blueprints. The blueprints are something else that are amazing, because if you want to do something like, an example, I don't know, if you want to do an end-to-end scenario for agents in an intelligent, yes, there it is. Thanks, Anna. If you want to do an end-to-end scenario for agents in a warehouse, you have here all of these. And remember when Don mentioned about that we have some models, but then we have the retriever, and we have another components in the NeMo family. So this is a place where you can do everything, and you have all of the components, all of each one of the pieces of the diagram. And because we love GitHub, you can even go here and see the full source code of the solution here in GitHub. So you can fork it, take it in your own. So go here, fork it, take it under. I'm not going to fork it because I have a GitHub account, which is I don't know, I'm getting used to my new GitHub role, and I don't want to show stuff that I am not allowed to show. But hey, you can fork it, take a look at the code, everything is here, and yes, you're going to start. So it's open source, yes, you have the code to do everything. We have another question before I move on from Alden. Any demos that show the full AIQ blueprint in action? I mean, I don't have it here. I'm sure that there are demos there because I saw the blueprint from the AIQ. So I don't have it up and running here. I'm guessing that in one of the NVIDIA shows, they're probably going to show it. Otherwise, we can deploy it and we can book something for the future, because that's that's the one that you talked on, yes? The AIQ for Durag. So yes, I put a pin here to promise that we can show this as part of the demos in one of the future sessions. Remember that this is a series. We are going to keep talking about NVIDIA, Foundry, partnerships, what you can do. So I'm going to try to work with the next speakers and the next team that is going to do this to also show that. But yes, it's a must-have, a must-show there. Sorry, I derailed myself. I like to talk. I'm excited about this. So as I said, we have the models. We are running the models. The models are working, and they are very good. I find it easy to do. So my next step was, okay, let's run this with a server. So what I create here was, in the scenario number 4, I have here a client-server application hosted by Aspire, where I have the server, I have a client, which is a web page, and then I have here an NMI. I have here something else. Something is important. And the server, it's literally a Python application that is going to create a Flask, a FastAPI server, where I am going to create a web server, load the model, provide an endpoint, and run it there. And it's kind of nice. I make it work. The client is going to upload the file, is going to drop the file, is going to get the transcript, and it works. Let me show you how it works. And to show this, I'm going to use a video because it's faster. So this is the Aspire. I'm using Aspire to coordinate everything. Aspire is a free tool that we have where you can define which is your backend, your front end, and it's automatically going to manage the service discovery, traceability, and more. So it's launched all of the services. This is the Aspire front end, which is what we call the dashboard. And we see here in the logs that this is the NIM logs. And I put a pin on NIM. I'm going to show it later, but we are going to talk about this later. But this is one of the components that we have out of the box for developers there. So I have a NIM that is going to load one model. Then I have the API server, the one that I show you, that I created, that is also using Python, and it's using the NeMo framework to load the model and expose the model to do inference in a couple of endpoints. And then the front end, and this is the connection, where you see that you have the API client talking to the API server and to the NIM LLM. And the front end is a Blazor application. This is a web application where what you can do, you can select the file here. I'm going to drag and drop a file here, an MP3 file. And then in the configuration options, what you can do is select the model that you want to use. Here is support Parakeet and the other one. And then we have the option to start the transcription. So after a couple of seconds, it's going to start the transcription. And again, the first time is going to take a couple of seconds because it's loading the model in memory. This is a microservice, and you use it and you warm it up, the model should be there, and after a couple of seconds, we are going to have the transcription. What I really like about this is that when I was learning this, and this is the moment that I was talking with Don, I started to learn. If we go to see the logs, you can see all of the progress bar there is how the model is being loaded in memory. So at the end, and this is the end of the transcript, and we have the endpoint. So we have here the, hey, hello, here, there is this Bruno, has been following my blog, and yada, yada, yada. So we have the transcript. But what I really like about this is that I created that FastAPI server to do the inference and more. But remember when Don was showing a slide how you have the chance to do NIM and to use NIM, which are templates, Docker container, in example, which are ready to do this. Hey, this is amazing. I mean, I did my best, but there are people who are much more intelligent than NVIDIA who created an amazing image that is already done that. You want to take a look here at that? What you can do is, in example, if you go here to one of this is the one that I'm using. If you want to your catalog and you are logging with your account, you can get here to one of the models that are supported in the NCG catalog, which is, an example, the Llama 3.2, and then you can get the container here. And this is a Docker image that is already ready to create a FastAPI server and expose a set of endpoints that are going to allow you to use this. And as Don mentioned before, this endpoint, this is a chat model. So this is a standard inference model that uses the OpenAI standards. Is going to have the same interface that we've been doing with OpenAI and the other, with the same interface that we know how to do it. So you can use any SDKs to chat with this. So in my application, in my demo application, the next step is, okay, if I already have this ready to go, if I already have my transcript, why not use a model like Llama 3.2 to analyze the full podcast content, and then when we have the full podcast content, create a couple of suggestions for the title or the tags or the description and more. And this is what I did. Let me show you the third part. And by the way, this is all in the repo. If you want to test it, this is what I did in the third part. Let me show you here where we have a NIM running, and it's running there. And I can go and pick up a transcript. So I'm going to open one of the transcripts that I have here in the output. I'm going to pick up one of the big ones. So it's not just a 30 seconds. It's one of the full ones. This is a 30-minute transcript. So we are going to see the full info here. So we have also, by the way, it has all of the format at one and the start and the end of the time and more. And then I'm going to ask to generate the podcast episode metadata. After a couple of seconds, what we are going to see here is, again, the model being loaded in memory. And when the model is loaded, after a couple of seconds, we are going to start to see how NIM is working. And hey, I didn't need to do anything. I needed to create my inference server, my web server, and more. This is a Docker container. This is an image that is ready to use. And what I like about this, and as soon as it finishes, I'm going to show, that is the same image that we are also using in Azure. So when you deploy a model in Azure, this is literally what you have. And you can see here that this is what we have. We have the title, we have the description, and a couple of tags. But as I said, if we go back to Azure, let me close my video, and I go to the Llama model, the Nemotron Llama model, we can see here that is using the NIM image to be deployed, the last image that was updated on September last year, that have everything there. So it's the same image that you're using here, but it's also being used in Azure. And this is the moment that I'm going to ask Don to keep me honest. And this is because all of this is ready to be enterprise grade, everything. So security and more. That's correct, Don?
Yes. Our philosophy is to make all of our software open source, make it available to developers to play with. If you're starting to get into NIM, where we've done a bunch of optimizations, that's great. Means you'll have a better impression of the whole thing when you play around with it, and that's good. When you get serious and you're going to deploy it as an enterprise application, that's when you want to talk about potentially getting a license to. It's still open source and free, but you're going to want the support with that. So when a CVE comes in and patches very long-term support and short, branches off of it, and all the things you expect for enterprise class support will kick in when you're ready to deploy at that level.
Yes, an example, this is the container already deployed in Azure, where you see here, I've been using this, so I may have something. No, I think it's automatically clean the log stream. Yes, this is enterprise. It's clean itself. It doesn't it's optimized to be very, very responsive and more, but this is the same here. And if someone wants to deploy this in the scenario number 4, in the documentations here, there is the Azure deployment where you are going to see if you are familiar with Azure, this is the ABC. Let's create a resource group. I like to have application insights to track everything that happens here, to have some kind of real-time monitor what's happened, then create a container registry, and then push everything there. So this is kind of the fun part. I saw a couple of other questions, but what I want to do, I want to try, because I showed you the video, but I didn't run this in the morning. Let's try to run the voice agent locally. So I'm going to do scenario 5, and I think it's here. Let me check my code. Yes, I think it's just Python app.py. Oh, I didn't share my desktop with audio. Oh, that's so bad. You're not going to hear if I talk with my super amazing application. So this is, let's refresh this. So this is the agent working. First time is going to take some time, so let's put this one here so you can take a look at the logs. Let's do it in the other way, because it's going to load the model. But if I go here to the smart mode, and I'm going to use Tiny Llama or Phi3, another model that we have here, and I said, hey, hello, I have a question. What is the capital of Spain? What we are going to see here is, we see here in the left that, remember, first time taking some time because it's going to load the model. And this is what you really need to do. But after the model is loaded, and you see here we have the transcript. Hey, hello, I have a question. What is the capital of Spain? And I have an accent. So I am kind of the challenge question here. I am not the easy user. And you can't hear it because I didn't share this with audio. Sorry about that. But it said to me the capital of Madrid, Spain is Madrid, located in autonomous community of Castilla-La Mancha. And I was born and raised in Argentina. I live in Spain. My family is from Italy. Now I am in Canada. I love soccer. So let's do another question. Let's try to find Tiny Llama. Who won the World Cup, the Soccer World Cup on 2022? It's speaking. Sorry that you can hear it, but have you seen how fast this work? How fast is the work? Get the audio super fast, get the response super fast, and this is all running locally. Imagine if you move it to the cloud. It's literally mind-blowing. And by the way, this is scenario number 5. You can use it. It's all there. And hey, I'm going to ask, I don't know, I don't have any other question. I don't want to push my luck anymore. I didn't have any errors here, so this is weird. When you are doing live demos, the demo gods are with me today. Hey, we have some last-minute thanks here. A question about Fabric. Will be there integration with Fabric here? I will say yes. I mean, there are models, and you can do data analysis, data ingestions, and more. I'm guessing that, yes, you can use some agent plus models and more in Fabric. I probably need to figure out a better scenario there. But yes, Fabric talk with agents, and we talk about that agents are all A2A agents and more. So I'm guessing that we can do something. I don't have any question there. And sorry, any scenario that I can bring here. And I think we are close to the end. So unless I see another last minute questions, or Don, you want to add something else, we can probably give back this to Anna to wrap up. I don't know. Don, something else that I missed?
No, I'm good. Thank you very much. That was excellent. Good to see it in action.
Yes. Sorry, Anna, all yours. Thanks, everyone.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.